Dear students, welcome to lecture series of the electrical engineering. In last lecture, the basic PN junction diode, its characteristics and special fabrication techniques are discussed. There are different types of the diodes. Having more than one PN junctions are available. These diodes have different characteristics, different fabrication and construction techniques, and different applications in special areas. So these types of the diodes are called special purpose diodes. In this lecture, I will discuss first type, that is Zener diode. Okay, at start I divide this lecture into parts so that you can understand each and every part of this lecture effectively. Okay, in first part I will discuss the basic operation and characteristics of the Zener diode. In second part, I will discuss how temperature affect the Zener diode operation. And in third part of this lecture, I will discuss about basic mechanism of breakdown voltages. And at the end of this lecture, I will discuss about applications of the Zener diode in different areas. Okay, let's start from basic principle and characteristics of the Zener diode. Zener diode is a device that operates not only in forward bias direction but also in reverse bias direction after breakdown voltage. After breakdown voltage. Okay, so basically Zener diodes are constructed or manufactured specially to operate in reverse breakdown voltage, reverse breakdown region. Okay, let's discuss characteristics of the Zener diode. Okay, in last lecture I discussed there are two basic biasings of the diodes, general purpose diodes, PN junction diodes. Okay, forward biasing, reverse biasing. Okay, let's see how Zener diode operate in forward bias direction and how operate in reverse bias direction. Okay, in forward bias direction, Zener diode operate same as conventional general purpose diode, but basic construction and manufacturing of the Zener diode is to operate in reverse breakdown voltage, reverse breakdown region. Okay, in forward bias region, same operation as PN junction diode, but in reverse biasing, Zener diode is operate in reverse breakdown region. Okay, let's explain with diagram for better understanding how voltage current characteristics of Zener diode used to know about the operation. Okay, so this is basic general voltage current characteristics of general purpose diode. Okay, from basic concepts we understand the operation of the Zener diode and region of operation of the Zener diode, how Zener diode operate in specific region. Okay, so this region is called forward bias region and this is called reverse bias region, and this voltage is called breakdown voltage or Zener voltage. Okay, Zener voltage vary from 3 volts to 300 volts according to the classification and type of the diode. Okay, so Zener voltage, this is the region, this is the region where Zener diode operate. This is the region. Must know about this operation. Okay, so forward biasing, this is 0.7 or 0.3 in case of different materials, and this is I out. Okay, from this diagram you see this point is I out, and from here to here current is constant. Okay, so after this point, after this knee point, okay, current change drastically but voltage remains constant. So this point, after this point, operation of this diode starts. But there is little bit problem with this type of drastic change in current. What type of problem and how to remove this problem from basic concepts of the circuit analysis. Okay, when current changes drastically, it means resistance of the Zener diode is very much small. When resistance of the is very much small, then what happens? Then power dissipation happens here. When power dissipation happens here, then there is a chance, there is a higher percentage that diode may damage. So how to remove this problem? This problem is removed by using the Zener resistance that control, that limit the current and reduce the power dissipation and reduce the possibility of damaging the diodes. Okay, this is basic concept. So this is the basic operation and characteristics of Zener diode. Now let's see what is the basic equivalent circuit of the Zener diode. So equivalent circuit, equivalent symbol of the Zener diode is this, and current is flowing here. Okay, this is equivalent, this is the basic symbol. A is symbol. Now how to draw the equivalent model, equivalent circuit of this symbol? Okay, from this diagram I will show you how equivalent model is created. Okay, from after this point voltage is constant and current is changes. So this is can be written as plus minus voltage source, because voltage is constant. We can represent this symbol with battery. Okay, so this is the basic equivalent circuit. Okay, so this is the basic circuit, and now we will see how temperature affect the Zener diode voltage, Zener voltage. Okay, how temperature, effect of temperature on Zener diode, effect of temperature on Zener diode. Okay, effect of temperature on Zener diode. Zener voltage changes with temperature, But there's a little bit concept to understand how temperature, how Zener voltage varies with respect to temperature. Okay, the percentage of the change in Zener voltage for every centigrade change in temperature can be measured in temperature coefficient. Okay, so temperature coefficient formula is temperature coefficient equal del Vg T1 minus T0 and 100%. This is the percentage. So first, this is del Z. Del Vg is change in Zener voltage. Change in Zener voltage. Okay, change in Zener voltage. T1 is change in temperature. Change in temperature. Okay. Second is T0 is normal temperature of the room. T0 is normal temperature as 25 centigrade. Normal temperature. 25 centigrade. Okay. And Vg is basically Zener voltage. Okay. We can also classify the diodes on the basis of temperature dependency. For example, diodes which have Zener voltage up to 6 volts can be having negative temperature coefficient. Okay, so there are two possibilities in this equation. For example, if temperature coefficient is positive, first is temperature coefficient is positive. When temperature coefficient is positive, what happens? When temperature coefficient is positive, then temperature is directly proportional to change in Zener voltage. Okay, so Vg is directly proportional to temperature. If this is not shown to you clearly, then I repeat again, Zener voltage is directly proportional to temperature. Okay, it means when temperature changes, when temperature increases, then Zener voltage increases. When temperature decreases, then Zener voltage decreases. Okay, directly proportional. You understand basic concepts. Okay, so second is temperature coefficient is negative. If negative, temperature coefficient is negative, then Vg is inversely proportional to temperature. Means when temperature increases, then Zener voltage increases, and when temperature decreases, then Zener voltage increases. Inversely proportional, inverse relation. Okay, so there are two basic possibilities. Okay, when Zener voltage is less than 6 volts, when Zener voltage is less than 6 volt, it has negative temperature coefficient. Negative temperature coefficient. Okay. Second point is when Zener voltage is greater than 6 volts and less than 300 volts, positive temperature. I repeat this, if you not saying it clearly, negative temperature coefficient and positive temperature coefficient. If Zener voltage is less than 6 volts, positive temperature, in the negative temperature coefficient. If it's greater than 6 volts, is positive temperature coefficient. basically concepts. Okay, so this is the basic effect of the temperature on Zener voltage. Okay, now we will see about the basic breakdown mechanism of the Zener voltage. Breakdown mechanism of the Zener voltage. Breakdown. There are two types of the breakdown mechanisms for Zener diode. Okay, first is Zener breakdown and second is avalanche breakdown mechanism. Okay, Zener breakdown and avalanche breakdown. Okay, Zener breakdown and avalanche breakdown. There are two types of the mechanisms. Okay, Zener, so let's explain it quickly. Zener breakdown occurs. Zener breakdown mechanism occurs when voltage is less than 6 volts. Okay, when voltage is less than 6 volts, and avalanche breakdown mechanism occurs when voltage is greater than 6 volts and less than 300 volts. Okay, so this is the reason. So Zener voltage happens. This Zener voltage is specified on data sheets of the diodes. Okay, there are very two types of the mechanisms. So this Zener breakdown region has negative temperature coefficient. Negative temperature coefficient. It has positive temperature coefficient. Okay, so this is basically difference of Zener breakdown region mechanism and avalanche breakdown mechanism. Okay, first difference is voltage and second is temperature coefficient. And okay, now what are the basic applications of the Zener diode? So applications. Applications. Zener diodes are used in voltage regulators. Voltage regulators, also used in clippers and also used in different types of the clampers. And protection devices, protection systems. Okay, so this is the simplified and explained way about to understand the Zener diode. Okay, everything is about is explained in this lecture. Okay, from basics to advanced, everything is in this lecture. Okay, so अगर हम कंपेयर करें Zener डायोड को जो हमारा जनरल पर्पस डायोड है, तो हम उसको जनरल पॉइंट्स में डिस्कस कर लेते हैं. जनरल से कुछ पॉइंट्स हैं वो आपको बताता हूं मैं. आप अपने माइंड में जनरल पर्पस डायोड को रखें और इसको एक्सप्लेन करें. ओके, इन जनरल पर्पस डायोड reverse bias resistance is very much high, so that there is no current in reverse bias direction and there is no conduction in reverse bias direction. But in case of the Zener diode, reverse bias resistance is very much small, so that current is flow from reverse bias direction and can be operated in reverse bias region, reverse breakdown region. Okay, this is simply basic difference. Okay, another very much important difference between the Zener diode and general purpose diode is the power dissipation. Okay, that is very much important point you have to focus on is power dissipation. Okay, for different applications you have to know about this property, because if you not interested and you not know about this property, then your equipment can be damaged. Okay, so in Zener diode, power dissipation capability is very much high as compared to general purpose diode. So this diode is used for the applications which where general purpose diode is not used. Okay, this is the explanation about the Zener diodes. Okay, so hope you understand this lecture very much clearly, because this is the simplified way to understand the Zener diode. Okay, so everything in this lecture, if you think there is a question to understand this, then comment us. We will reply you, and मिलते हैं फिर next lecture में. Till then, stay blessed, stay inspired. Thanks for watching.